As we continue our adventure in nomenclature, I want to turn to the variable charge cations, our transition metals, because these are going to be a very special way of naming, and we have to pay very close attention to what we're doing in order to name them properly. All of our transition metals are going to be in group 3 to 12. The transition metals are going to have variable charges. We don't see a definite pattern like we saw with the group 1, group 3, and group 13 elements having a particular charge based on their group. As you see in the examples below, the charge can be 2+, it can be 7+, it can be 1+, we can go up to 9+. Most of the time though, we're going to have to deal with the charge based on determining a Roman numeral. So if you look at the example below, let's take a look at chromium 2+. We write the name chromium out as it would appear on the periodic table, but we indicate it as a 2+ charge by putting the Roman numeral 2 inside parentheses at the end of the word. This is very important. Every time we have a transition metal, we must indicate the charge by putting a Roman numeral after the name of the metal. If we don't do that, we would be writing the same name for multiple different species of that ion. And if you go into a lab and you grab chromium 2 oxide and you want chromium 3 oxide, it's going to give you a very different reaction and different outcome. So you have to make sure that you're writing the correct Roman numeral when you're doing these namings. Now, when we go to name our compound, when we use transition metals, we're still going to start by putting the metal cation name first. We're then going to add the Roman numeral to determine the charge. Most of the time, to determine the charge of a transition metal, we have to look at how many counter ions are present. If we have 2 chlorides, it would be a 2+ charge. If we have 3 chlorides, it'd be a 3+ charge on the metal. If we have an oxide and we only have 1, then the metal's a 2+ charge. But if we have an oxide and there's 2 present of the oxygens, then we have a 4+ charge. So you're going to be using the charge of the counter ion to determine the Roman numeral that you're going to put when you have to deal with multiple charges in transition metals. Once you determine the metal name and its charge, then you're going to put the nonmetal ion name second. So let's take an example. CuCl2. Well, Cu is going to be copper. There's 2 Cl units, and a Cl- is going to be chloride, so we're going to have a copper 2+ charge. Therefore, the name for the copper would be copper, parenthesis, Roman numeral 2, end parenthesis. Our chloride, again, is going to be a 1- charge, and we're just going to write that as chloride. So when we put the full name together, we're going to end up with copper, Roman numeral 2, chloride. And that's as straightforward as it is. There isn't much complication or much difference between dealing with transition metals and the monatomic ion names, except for putting a Roman numeral to distinguish the charge of the transition metal that you're dealing with. So now that we've learned to name compounds from their formulas with transition metals, let's work backwards. Let's get our formula from our name. We're going to follow the same process that we did before with finding the formula from the name of a monatomic ion compound. Here, first thing we're going to do is we're going to find the symbol for the metal and its charge. Then we're going to find the symbol for the anion and its charge. We're going to put the metal first and the anion second. Then we're going to use the superscripts to determine the subscripts. So let's follow our example of iron 3 bromide. Iron is going to be Fe. The 3 plus charge we're going to get from the Roman numeral. The anion is going to be Br, And it's going to be a 1 minus charge because it's a halogen that is a monatomic ion. When we put the two together, we're going to put the metal first, so we're going to have Fe3 plus and bromide Br1 minus. Now let's take our superscripts and make them subscripts. So we're going to take the superscript from the iron and put it as the subscript for the bromide, and then we're going to take the superscript for the bromide and make it the subscript for the iron. We're going to drop the 1 because we don't need to indicate it, and drop our charges, so we end up writing FeBr3. So iron 3 bromide is going to end up equaling FeBr3. Now, just like the last video, I'm going to give you some more practice problems, so you're going to want to make sure that you pause the video at this time and record these formulas, and then you're going to want to convert them from their formula to their name and bring it to class so that we can discuss it and do some more examples in class. And if you have any problem with these, make sure you bring up the ones that you have problems with during class so that we can discuss them as a class and go over them.